Hello GCC, welcome back to Chapter 5. So we just learned that Niels Bohr, about 100 years ago, said that electrons travel around the nucleus in these discrete quantized energy levels, and that they have to be on a level, not in between the levels. So we have level 1, 2, 3, 4, etc. So why did he think that 100 years ago? We can't see atoms. We certainly can't see electrons. Why did he think this? Well, he based this on the behavior of a gas when you seal it in a glass tube and plug it in, so give it electricity. When you have a bulb like this plugged in, it gives off light, like a neon sign. So maybe you've been to Vegas and you've seen all the different colors neon signs. They're not all made of neon, of course, but there's blue and pink and white and bluish white, yellowish white, gold, purple, various shades of green and blue. And so all these neon signs have different colors. Now, when you take the light from one of these bulbs and pass it through a prism, remember, a prism will separate the light into its component colors, and we get what we call an emission line spectrum with distinct bands of color. Let me show you an example. So let's pretend over here on the left we have a gas discharge tube containing hydrogen gas. When we plug this bulb in and give it electricity, it shines pink. But when we put the pink color through a prism, it separates into 4 distinct color bands. We get a violet, a blue-violet, a blue-green, and then way down here towards me, a red. So the pink color is those combined together, but when we put it through the prism, it separates these. Now notice in between the colors, there's a big gap of nothing. This is not a continuous rainbow. We do not see all the colors. We only see these 4 little lines. So, in a way, they're quantized, because we have a line, then we have nothing, then we have a line, then we have nothing. Just like the same way when you have a ladder, you have a rung and then nothing, and then a rung and then nothing. So in a way, this is quantized, and that's where Niels Bohr got the idea. Here's some other elements and their line spectrum. You can see they're all different from each other. So every gas is unique and has its own line spectrum, which provides its own unique color that we can use in light bulbs. Now this is an oversimplification, but basically let's say we have an electron in red going around a nucleus, which is the black dot in the center. So we have this red electron on the first energy level. When we give it enough energy through heat or electricity, if we give it the right amount of energy, it can jump from level 1 to level 2. So it absorbed energy. Now, when it returns back to level 1, it has to release the energy. And when it does that, it releases it in the visible spectrum as a red wave of light. So we can say that red wave of light is this red color for hydrogen, for example. So depending on how many electrons you have, depends on what kind of jumping occurs. We can jump from 1 to 2 and back, 1 to 3 and back, 2 to 3 and back, 1 to 4 and back. So we have different jumps depending on the electrons and the levels. And every atom is unique. So every atom is going to have its own jumps. So basically, when you plug in a light bulb, like a neon sign, a gas discharge tube, we have electrons jumping out and in. They jump out energy levels and back and release energy in the form of light. So that's kind of an oversimplified view of how a neon sign works. Cool. Catch you in the next video, GCC.